Now we want to factor trinomials in the form of ax squared plus bx plus c when a is equal to 1, meaning the first term is going to be x squared. So looking at our first example, the only common factor between these three terms is 1. So if this does factor, it's going to factor into two binomials. And the first terms of each binomial will come from the factors of x squared. And the second terms in the binomial factors will come from the factors of positive 32. But we don't want just any factors of 32. We want the factors of 32 that add to the middle coefficient, in this case positive 12. So we normally say we want the factors of c that add to b. Well, there's only two factors of x squared, that would be x and x. So the main challenge for this problem is to find the factors of positive 32 that add to positive 12. Well, let's list the positive factors of 32. We could have 1 times 32, 2 times 16, 4 times 8. But again, we want the factors that add to 12, so 4 and 8 are the winning factors. And since 4 and 8 are both positive, we'll have plus 4 here and plus 8 here. Of course, we could put the plus 8 here and the plus 4 here, and the factors would be the same, just in a different order. If we want to verify this, we can multiply this out. We'd have x times x, that would be x squared. And then we have x times 8, that's plus 8x. Then we have 4 times x, that's plus 4x. Then we have 4 times 8, that's plus 32. So we do have x squared plus 12x plus 32. So all these factoring problems can be verified by determining the product of our factors, but this would be our trinomial in factored form. Let's take a look at another example. The first thing to notice here, the only common factor among these terms is 1. So if this does factor, it will factor into two binomials. The first terms will come from the factors of x squared, that would be x and x. The second terms will come from the factors of negative 60, but we want the factors of negative 60 that add to positive 11. Let's list some of the factors of negative 60 and see if we can find the pair that have a sum of 11. Well, we'd have negative 1 times 60, negative 2 times 30, negative 3 times 20, negative 4 times 15, negative 5 times 12, negative 6 times 10. Now see if any of these have a sum of positive 11. Well, negative 4 plus 15 would have a sum of positive 11, so these are the winning factors. Since one factor is negative 4, we'll have x minus 4. And since one factor is positive 15, we'll have plus 15. Here's our trinomial in factored form. In our next example, again, the only common factor among these three terms would be positive 1. So if this does factor, it'll factor into two binomials. The factors of x squared, x times x. And now we want the factors of positive 20 that add to negative 9. So if we want the factors of positive 20 that add to negative 9, notice both factors will have to be negative. So we'd have negative 1 times negative 20, negative 2 times negative 10, negative 4 times negative 5, and negative 4 plus negative 5 is equal to negative 9, our middle term, our middle coefficient. So we're going to have x minus 4 times x minus 5. So here's our trinomial in factored form. And in the last example, we have x squared minus 5x minus 24. The only common factor among these three terms is 1. So again, if this does factor, it'll factor into two binomials. The factors of x squared would be x and x. And now we want the factors of negative 24 that add to negative 5. Let's try negative 1 times 24. Negative 2 times 12, negative 3 times 8. I think I'll stop here because notice that negative 3 plus 8 would be positive 5. And since we want a negative 5, we can just change the sign of these factors. If we use a negative 8 and a positive 3, these two would have a sum of negative 5. So we have x minus 8 times the quantity x plus 3. And now it's factored. Hope you found this helpful.